ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
This course is on digital circuits and digital systems. You see, we have this signals. Signal is a variation in a parameter, physical parameter. Temperature variation is a signal. Speech, as I speak now, is a signal. Video is a signal, it's a light intensity variation. Now, all these signals, any of these signals that you get need to be maybe processed to be available to the other end and maybe stored. So, you do a lot of processing of signals in real life. For example, take a microphone. The signal, the speech signal that you give into the microphone, if necessary, it needs to be amplified and then given out as a signal out of the speaker, the sound signal out of speaker. So it's a typical signal processing scenario. Basically, a signal in the electrical, we are in the electrical engineering domain. We talk about only electrical signals. That means a variation of an electrical quantity, a voltage or a current, as a function of time. A signal is defined as a variation of an electrical quantity, usually a voltage or a current, with time. Of course, you can also have a signal which does not change with time, then it's not called a signal anymore, it's a DC value, we will say. For example, if you know that the value is not going to change, there's no need for processing. You know that the value, so you can use the value wherever you want to use it. Now, once you have this variation, any signal that naturally occurs, the speech or temperature variation, or as I said, the illumination changes in the television, or a seismic earthquake activity, any signal, first you need to convert it into electrical variations. Some of them are mechanical, other parameters, other physical parameters. So there is a transducer, a sort of a device. This device which converts non-electrical quantity into an electrical quantity, electrical signal, is called a transducer. So the output of the transducer is an electrical signal, where we define the signal as the variation of the parameter of interest, a voltage or a current, with time. Normally a signal can take any value, of course within a given limit, and at different instants of times. A signal varies continuously. for example, you have a time variation of a signal, voltage level of a signal with respect as a function of time. If I plot like this, there are any number of values this signal can take as a function of time, but of course it is always limit. What is the minimum of this? Let us call this minimum value 0 and maximum value V max. Two different values to define, two values to define and say that signal always varies within this range. This is the range of the signal. And at any instant of time it can take any value, and what is the instant of time is also not defined. I can make a measurement here and immediately at the very next instant of time, or I can do a measurement here and do it much later here. Nothing is defined here. This variation of signal which can take any value between these two limits, such a signal is called analog signal. Analog signal or analog quantity can take any value at any instant of time within, of course, the limit defined, within the range specified. On the other hand, I want to process the signal only at discrete instant of time. Suppose I want to monitor the temperature of a system every minute or every hour or every 30 minutes, whatever. You discretize the time at which you look at the value of the signal. The signal will vary continuously all the time, but you are looking at only at the discrete instance of time, at definite instance of time. Only then you are looking at such a signal. Supposing I put this value, I will have equal intervals for time. So I call this T0 or the starting level point, T1, T2 need not be equal. Just to make it explanation easier, I make it equal instance of time, equal intervals of time, like that. So I monitor the value of the signal V of t at instance of time T0, T1, T2, T3, T4, as long as I want, as long as I am interested in the parameter. Such a signal is called a discrete time signal. So a continuous variation signal still continuously varies. The analog signal only. An analog signal is a signal which can take any value between the two defined limits as a function of time. But even though the signal varies, I am only interested in looking at it at specific intervals of time. Such a signal is a subset of the analog signal. That is called a discrete time signal. The problem in these two cases, whether you want to continuously monitor, what is continuous? Finally, it has to be discrete. Even if it is 1 microsecond, then what happens between these 1 microsecond? Even if it is 1 nanosecond, something can change in between these. Finally, we can only observe. Physical parameters will vary, input, output, but if you become an observer, the observation can only be discrete. Is that right? Okay. But whether it is a discrete signal or a discrete time signal or an analog signal, the variation of the signal between the two limits is a continuous variation. There is no defined points by which it can vary. What I am saying is, supposing my initial value is 0 volts and V max is 5 volts as an example. As an example, I make this 5 volts. I am only allowing the signal to vary from change from 0 to 5 volts. Within this 0 to 5 volts, it can take any value. You may have difficulty in representing because of a limitation in the digits that you are having in your computer calculator, or I cannot represent any number beyond a particular number of digits to be meaningful. But theoretically, it can take infinite number of levels between 0 volts and 5 volts. Now, when you are trying to transmit a signal. Because after all, what is the process of the signal itself has no meaning unless you use it somewhere. There is a change in the speech. I speak. My speech is picked up with the microphone and converts into electrical signals. The electrical signal is amplified by an amplifier.